Goals is a bit different when it comes to gameplay and animation because we want to be gameplay first, where other sports games are more animation driven, where we are gameplay driven. So the benefit is designers and programmers can do a lot of tuning to the gameplay without waiting for animation to do those changes. Instead, it's the opposite. They can make the changes, and then if we build a smart enough animation system, it can kind of adapt to whatever changes designers make and tweaks they want to make to the game design. Animation will just keep up. But the challenge with that is when you actually want animation to look good and you want the players on the field to look like they're the ones driving the action and they are grounded and belong in that world. The hard part is when animation is following gameplay, how can you make it so that it looks like it's the opposite? It's the reverse. Animation is driving the events. To expand a bit more on the difference between animation-driven and gameplay-driven, you need to understand a term called root motion. So what root motion means is the movement that's baked into the animation on the root bone drives the movement of the character in the game. Where gameplay-driven, which is also called like code-driven or physics-driven, that on the other hand is completely, it doesn't care about animation at all. The system is basically taking an input from the player and applying velocity to the character in the game. The animation itself has no control over what the character is doing in the game. It's only following along. Yeah, so we're using Unreal Engine, and we are leveraging some animation tech that they've added somewhat recently that I've been really, really impressed with, and I think it's going to be like a core part of the animation system for our game. The three things that we are utilizing are stride warping, orientation warping, and distance matching. So what stride warping does is it will adjust the stride length of the legs to match the in-game speed. So for example, we have a run animation that runs at like 5 meters per second. And then in game, let's say the physics of the character is moving at 4 meters per second. What stride warping will do is it'll actually like scale the length of the stride so that the feet match 4 meters per second instead. You can see here, orientation warping, we have a character, we have just a single run forward animation. But then if we kind of steer the character so that they're running maybe like 30 degrees, what orientation warping will do is it'll actually rotate the legs and the lower body to match that direction of the character's moving, then counter rotate the upper body so they continue facing straight ahead. Distance matching, similar to orientation warping and stride warping, it tries to modify the animation to match what the actual in-game physics, in-game character is doing. For our use case, we're using them for like stops and starts. So they will modify the start or the stop animations so that the actual distance traveled in the animation matches the distance traveled in the actual game. So we kind of leveraged the Unreal's data tables and we created a custom animation node. So we have a database with, let's say, all the shot animations, and it'll see like what's the power of the shot, what's the angle of the shot, and then it'll look through the database, find the best matching animation, and then that's what the animation system will play. So the two things that we care about is like one, when the actual event, the action happens. For example, if it's a pass or a shot, like what frame of the animation does the kick happen on? That needs to be timed with the action of the gameplay. And then we have a beginning portion animation. We can set a range, a window of frames that we can basically, the system can choose to start on. And designers can go in and they can change the values. They can say like, okay, we want this shot to take longer to execute or to be faster. And as an animator, we can just let them do it, and the animation syncs up in timing, and it works really, really well. So creating those two pieces of custom tech for us has been really huge, and I've been really happy with that. We still have a lot of interesting challenges to solve in animation. Some of the big ones are keep the animation in sync with the physics and the character in the game when they do things like turns, like 180 turns, or if they're dribbling. Because let's say we have a dribble turn animation and that animation is made to go at like 90 degrees exactly. So in the game, the player could actually do a dribble to the left, maybe 80 degrees or 110 degrees. But we can't do an animation for every single possible permutation that they could turn. So we want to play a 90-degree turn animation, but we want to warp it and change it so that it actually follows the path of the actual physics in the game. We need to develop an IK system that will allow us to make proper contact with the ball. So right now we don't have that, so the feet and the ball don't align. The events will happen at the same time and you might not notice, but the foot actually sometimes doesn't actually reach the ball. We're going to build an animation system that is very flexible, looks great, works well, but it's also very game designer friendly in that they have power and control to make changes without hurting the visuals of animation. That's really, really exciting. Animation ain't no fucking joke.